Hello everyone and welcome back. Let me start with a simple but exciting thought. Imagine you've just joined your first job. Your starting salary is rupees 8,000 per month and every year you're promised a fixed increment of rupees 500. Sounds good, right? Now, in the second year, your salary becomes 8,000 plus 500, that is 8,500. In the third year, it turns into 8,000 plus 2 times 500, which equals 9,000. And by the fifth year, it's 8,000 plus 4 times 500, giving you 10,000. So the sequence of salaries looks like 8,000, 8,500, 9,000, 9,500, 10,000, and so on. Notice something? Every year's salary increases by the same fixed amount, 500. That means this forms an arithmetic progression, or simply, an AP. Isn't that fascinating? Your career growth linked to a neat little math sequence. Now let's zoom in on this pattern. Look carefully. The second year's salary is equal to the first term, which is 8,000 plus 1 times the common difference, which is 500. The third year's salary is equal to 8,000 plus 2 times 500. So in general, the nth year's salary follows the pattern A sub n equals 8,000 plus bracket n minus 1 bracket into 500. Here A is the first term, which is 8,000, and D is the common difference, which is 500. This pattern shows us something powerful. We don't need to keep adding 500 again and again. We can jump straight to the year we want using a simple formula. So what exactly is this formula? Let's start from the beginning. Suppose an arithmetic progression has first term A and common difference D. Then the second term is a plus D. The third term is a plus 2D. The fourth term is A plus 3D. If fx is equal to fx, we follow this pattern, then the nth term, written as A sub n, becomes a plus bracket n minus 1 bracket into D. This formula works for every natural number n as long as the difference remains constant. And remember, A is the first term, D is the common difference, and nth term of an AP, A sub n, is the nth term we want to calculate. This formula is like a magical shortcut. It saves us from long and repetitive calculations. Let's put this formula into action with an example. Consider the arithmetic progression 2, 7, 12, and so on. Here, the first term A equals 2. The common difference D equals 7 minus 2, which is 5. Now, let's calculate the 10th term. According to our formula, A sub 10 equals a plus bracket 10 minus 1 bracket into D. That means A sub 10 equals to plus 9 into 5, which equals to plus 45. And that equals 47. So, the 10th term of this AP is 47. Notice how quickly we reached the answer without adding 5 again and again 9 times. That's the real power of this formula. Ready for something a little more interesting? Let's try another example. Suppose we have an AP 21, 18, 15, and so on. Here, the first term A equals 21 and the common difference D equals minus 3 since the terms are decreasing. Now, let's say we want to find which term of this AP is minus 81. We start with the formula A sub n equals a plus bracket n minus 1 bracket into D. Substitute the values. Minus 81 equals 21 plus bracket n minus 1 bracket into minus 3. Simplify it. Minus 81 equals 21 minus 3n plus 3. That means minus 81 equals 24 minus 3n. Rearranging, minus 105 equals minus 3n. So n equals 35. That means minus 81 is the 35th term of this sequence. Amazing, right? Even when the numbers get negative, the formula still works perfectly. Now, why should we care about this formula? Because it has so many real-life applications. Salaries, like we saw, installments in loans, savings plans in banks, all of these often form arithmetic progressions. But there are some common mistakes students make. For example, they sometimes use the wrong formula, A sub n equals a plus nd. That's incorrect. The correct formula is a plus bracket and minus 1 bracket into d. The minus 1 is crucial. Another mistake is forgetting to check whether the value of n comes out as a positive integer. If f(x) is equal to f(x), it doesn't, then that term does not exist in the sequence. And remember, this formula only works if f(x) is equal to f(x). The common difference is truly constant throughout the sequence. So, let's wrap this up. The nth term of an arithmetic progression is given by the formula a sub n equals a plus bracket and minus 1 bracket into d. This formula comes from the simple idea of repeated addition and helps us calculate any required term directly. We saw how it works in increasing sequences, decreasing sequences, and even for finding the position of a specific term. And the best part? It's not just theory, it connects beautifully to real life, from salaries and savings to seating arrangements and beyond. And that, my friends, is the foundation of the nth term of an AP. In the next video, we'll explore how to find the sum of the first n terms of an arithmetic progression, another fascinating journey. Until then, keep exploring, keep questioning, and keep enjoying the beauty of mathematics.